Hello everybody and welcome back to Chem Talk, where today we'll be talking about the law of conservation of mass. So what is the law of conservation of mass? So during a reaction, we must establish that no mass can be created during a reaction, nor can it be destroyed during a reaction. In other words, this means that all of our reactants in the reaction must equal the mass of all of our products. So the mass can change forms, and it can change from states, such as from a liquid to a gas, but the mass of the reactants must stay the same as the mass of the products. So it doesn't matter whether or not you're changing things, you're making new compounds, you're breaking compounds apart, and you're putting new ones together. The mass of the reactants must equal the mass of our products. Now, there are two different types of systems, and mainly we're going to focus on our closed systems today. So a closed system is when nothing enters or leaves our system. So we're going to see that in this box over here, we have 7 particles of, let's say, reactant A. And when they react with each other, they make reactant B. And I want to point out that the mass, or our, let's say, 7 particles, stays the same in our products. So we still have 1, 2, 3, 4, 5, 6, 7 particles in our products. So in a closed system, nothing enters, nothing leaves. It's basically like a sealed test tube that a reaction is taking place. Nothing can enter our surroundings, but heat can still go in. And because of our change in matter, it might look like some mass is disappearing, but our mass is just turning into gas and we're unable to measure it. Sometimes you might be observing a reaction and you're going to be thinking to yourself, well, the mass of my solid doesn't equal the amount of liquid or aqueous solution that I put in previously. That is because we're not able to account for our gas that leaves as well. Being able to measure our gas is quite difficult, and when it comes to our open systems, it becomes difficult in order to measure the gas that has already escaped into the air. Like, for example, take into account making a exothermic reaction, and in an exothermic reaction we have H2 gas escaping. Now this H2 gas goes into the atmosphere, and since it's in the atmosphere, we can no longer actually separate it again and find the mass. This is why the law of conservation of mass is so important. We can find the amount that has been produced from our total mass from what we already have. Now we're going to go through a couple of practice problems and kind of show how we can use the law of conservation of mass to find unknowns in our reactions. Now, with the following, we are going to use the law in order to figure out the missing information. I've already balanced all these equations, so the only thing you really need to worry about is the law of conservation of mass. So in our first problem, we're going to see that 2 moles of our H2 plus 1 mole of our oxygen equals 2 moles of our H2O. And we're going to see we have 3.4 grams of H2 plus 10 grams of O2, but we don't know the total of our H2O or water that is produced. In order to find that, we are going to add our reactants together. We're going to see that our total mass of our reactants is the total mass of our products, and that's going to equal 13.4 grams. Because there's only one product, we only have to add everything up, and that's it. In the next example, we have 2 reactants and we have 2 products, and we have to find the mass of one of our products. So what we're going to do is we're going to write out our equation. Again, this has been completely balanced. So we're going to have our CH4 plus 2O2 react together, and that's going to make products of CO2 plus 2H2O. We're going to see that we have 12.2 grams of CH4 and 14 grams of our 2O2. We're going to see that we also know that we have 20.0 grams of our water, and we don't know how much carbon dioxide we have. So what we're going to do over here is we're going to add up the total mass of our products. And over here I did it on the side. 12.2 plus 14 grams equals 26.2 grams. And since we already know some of the product that exists, we're going to take our total mass that we found, subtract it by the sum product that we have in order to find the remaining amount of product, and that's going to equal 6.2. You're going to be asking, how did I know how to do this? That is because we want to continuously remember that our mass of our reactants equals the mass of our products. So because of the total mass, we can find that the total mass still equals the same on both sides. So you can just use the same number and subtract it by the amount of product that we already have in order to find the amount of product that also was created during this time. Now in our last example on this slide, we're going to see that we have 2 HGO, which Hg is, for those who don't know, is mercury and oxygen, and that's reacted into making 2 moles of our mercury plus 1 mole of our O2. We're going to see that our total reactants is 23.2 grams. This makes our life so much more easier. Now we know that there's one reactant and the total mass, and we can just go from there in order to find the remaining product that there is. So we're going to take our total mass subtracted by the amount of product that we know that is already there in order to find the product that we need to have in order for the law of conservation of mass to be true. So we're going to take 23.2 grams minus 13.0 grams, and that is going to be 10.2 grams. I'm going to show one last type of example here, and this is kind of going to be a little bit different, and it's going to show our math in a different way, and kind of something for those who are more on the algebraic side and kind of love finding variables. I'm one of those kinds of people. It just makes it a little bit easier to understand. So below we're going to see that we have reactant A, which is a liquid, and reactant B, which is also a liquid, and these two react in order to make product C, which is a solid, and product D, which is a gas. We're going to see that we have 3 grams of our A compound, 6 grams of our B compound. These two react in order to have 2 grams of our C compound, and unfortunately, because it was an open system, we have no idea how many grams of our D compound there were made. So because this gas was released from the system, what is the mass and why do we know that this is the mass? How do we verify that this is the correct number? So I want to remind everyone that our mass of products equals our mass of reactants. I'm going to say it over and over again, but this becomes very, very important once you go into more complex topics. So we're going to find our total mass of reactants. So that's going to be 3 plus 6 equals 9 grams of our reactants. And our mass of our products is going to be 2 plus x. We're going to find that the amount that we don't have, we're just going to put in a variable for now. We're going to have it as x. And because I previously mentioned that mass of products equals mass of reactants, we're going to be able to equate 2 plus x to 9. So this allows us to find our variable x, or the amount of grams of compound D that we have. Now we're just going to solve for our x regularly, and we're going to see our x, or the mass of our gas, equals 7.0 grams. Now you might be asking yourself, why are we going through such simple math? Why is it so important and everything like that? So right now we're working on very basic units of chemistry. We want to make sure that you have all the basics down, so when you go to all of these complex combustion reactions and organic chemistry labs and everything like that, you're able to see how something can turn into something else, but you can still keep the same amount. Say you're trying to find the amount of gas reacted together, and you unfortunately have an open system and some gas releases from the products. We're going to be able to find the amount of gas that we have because of the law of conservation of mass. So, the law of conservation of mass is very, very important, and it's really interesting. As well, it is something that most chemists, if not all chemists, have down before they can continue on into the rest of our chemistry units. Thank you so much for watching.